Okay, let's go over scientific notation for a little bit. Scientific notation is usually something that is used to describe huge numbers, numbers that are just too big to write down. If I'm trying to write down the number of girlfriends I've had, maybe I can write that number down. It won't take very long to do. But if I'm trying to find the number of centimeters from here to the moon, that's way too big. I'm not writing that number down. So scientific notation comes in handy when you're trying to write a number so big that you just don't want to write it down. You need a shortcut to say, hey, here's the number, right? So here's a few things about scientific notation. Scientific notation always starts with a non-zero digit and then has a decimal. The number of digits after the decimal don't always really matter, but you've got to have a whole number, a decimal, and then maybe a couple digits, like 1, 0, 0, 1, 7. Kind of depends what you're talking about. You want to look at it and try and round it, this back part, so that you're talking about. Then you have times, which we usually don't use x for multiplication, but scientific notation does use x for multiplication. So we've got 2.017 times 10 to the question mark power. It just depends on how many times you need to move this decimal to get to the actual number. Let's say it was the 13th power. So technically, this number right here is 2, and then I'm going to have 13 digits. So 0, 1, 7, there's 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And then this is where the real decimal would be. So let's try and get a visual representation of what this is. That's, the number of, I don't know. That's the number of squirrels in the world. You didn't know that, but it is. And so I usually don't try to write this number down. It's easier to write the scientific notation for it. Okay? So a few things about scientific notation. If you have a negative exponent, like let's say we've got 3.58 times 10 to the negative 7th power, a negative exponent, when I'm looking at the actual number, will move this decimal to the left 7 spots. So that a negative exponent tells us that this number that we're talking about is such a tiny number that we probably can't even see it. Maybe this is the number of, or the size of some bacteria. It's so tiny we can't even see it. Well, that's why it has a negative exponent. Okay, so positive exponent would make it a ginormous number. Negative exponent makes it a tiny, tiny number. So what happens if we multiply two scientific notation numbers together? So we've got 2 points, and I'm going to need a calculator on this, 2.48 times 10 to the 4th power times, and in fact, I'll put this in parentheses, 1.76 times 10 to the 10th power. Sure, that's good. Okay, so we got to multiply these two scientific notations together. What we want to do is, I look outside the parentheses, there's nothing there. I want to rearrange it. Since everything's multiplication, this times this times this times this, I am able to move things around and put the numbers that I want by each other. So I'm going to say 2.48 times 1.76 times 10 to the 4th times 10 to the 10th. And the reason why I'm doing that is now it's a little easier to try and group things together and figure out what is 2.48 times 1.76. So let me grab a calculator really quick and try it. .48 times 1.76. So I've got 4.3648 times. Now I'm going to do the tens. So I have 10 to the 4th power times 10 to the 10th power. When the bases are the same, we'll talk about this in another video, but whenever you're multiplying two numbers and the bases are the same, you add those exponents together. So this is going to be 10 to the 4 plus 10 is 14. I look at this. Is this in scientific notation? Is the decimal in the right spot? 4.3, yes, this is in the right spot. So I don't have to modify this to make sure it's in scientific notation. This is good. This is my scientific notation. If this would have been like 43.6, then I would have to modify this a little bit and make it so that way it is the correct scientific notation. I'd move the decimal back one and increase this by 1 to make it so it equaled the correct number. Okay, let's throw another one of those in. Let's make it so that way we have to modify it at the end. So let's say we've got 5.6 times 10 to the third times 3.1 times 10 to the 8th. That's a good one. Okay, so again, I grab a calculator. I'm going to rearrange this. I have 5.6 times 3.1, and then I'll have 10 to the third times 10 to the 8th. Okay, so let's multiply those. 15, maybe 16 point something. 5.6 times 3.1. A little off. 17.36. 17.36 times 10 to the, I add the exponents together, 11th power. Now, is this in scientific notation? No, it is not. So now I have to kind of modify this and try and figure out where is it supposed to be? How do I change the numbers to make this a valid actual number? So I know that I want the decimal to be right here in between the 1 and the 7. So it's supposed to be 1.736 times 10 to the, I don't know what this power is supposed to be. Does it stay 11? No, it's not going to stay. So does it decrease by 1, make it 10? Or does it increase by 1 and make it 12? Well, the way I do it is I just think about it. Some people have arrows pointing different ways and it gets confusing. I just think, what would this number actually be? If this was the number of hairs on my head, it probably would be wrong. But if it was, I can dream. I would move this decimal 11 spots this way, right? So 11 spots to the right, it's coming this way. Well, to put it back in scientific notation, I'd have to come back 11 spots, but then I'd have to go an extra spot to get where I want it to be. So that actually makes me move it 12 spots. So this is 1.736 times 10 to the 12th power. So in my mind, the way I do it, what makes sense to me, is I look at the scientific notation that's here and realize it's not correct scientific notation. What is this number actually doing? If I move it 11 spots this way and then come back, I would have to go 12 spots to get the decimal where I want it to be. So that tells me, this has to be the 12th power here. So another, just kind of breaking this down, like what if we would have had this as our final answer? Well, I have 0.034, so I know that it's supposed to be 3.4, that's where the decimal is supposed to be, times 10 to the, I don't know what this power is going to be. So in my mind, I'm looking at it like, okay, well, what number is this? If I move the decimal 6 spots to the right, and then I came back to see where it's supposed to be, am I going to go less than 6 or more than 6 spots to get back to the spot? Less than 6. So that tells me, okay, so it's 2 spots here, so it's going to have to be 2 less than that, so it's going to be 4 spots. This would be to the 4th power. You okay with that? Okay, so that's one way that's kind of confusing to people. Science class, you're figuring out molecules and distances, lengths of how far away is the moon from the sun, stuff like that. You need scientific notation. Same thing if you're dividing, just real quick, let's just do a division 1.78 times 10 to the 15th power divided by 2.1 times 10 to the 8th power. Okay, well, if you've had much practice with same base, different exponents, it's going to come in helpful here. But first, I'm going to divide this. 1.78 divided by 2.1 equals 0.8. Okay, I'm going to have to round on this one. So I've got 0.8. I'm looking to see where to round here. 476. Okay. It's a good spot. Good spot to round. Times 10 to the, I'm going to subtract these exponents instead of add them together because it's dividing. So that is 7th power. Is this scientific notation? Close, but not quite. This should be 8.476 times 10 to the, okay, I needed to move it one spot to get it where I wanted. So does this increase by 1 and become an 8? Or does it decrease by 1 and become a 6? The way I do it, I'm going this way 7 spots. If I come back, I only come back 6 spots to get where I want it to be. So that tells me it must have reduced by 1. So that is going to be a 6. Okay? I hope that helped a little bit. Some introduction to scientific notation. Hopefully if you have any questions on this, just let me know. Send me a message and I'll get back to you as quick as I can. But hope you have a great day and take care.